Hello everyone and welcome to another episode. In today's video I would like to show you a quick verification and adjustment of a thermocouple. This video is a response for one of my comments on that video about DIY BGA rework station. One of my viewers has a problem with popcorning his PCBs. So this is how to adjust a thermocouple using a 2-point calibration. Instead of trusting that factory accuracy, we will compare a probe against two known physical temperatures, and one going to be 0 degrees Celsius, which is melting ice water. The second one is going to be boiling water, which depends on altitude. So I am in Edmonton, so it's about 690 meters above sea level. So the water will not boil at 100 degrees Celsius. It's going to boil approximately around 97 degrees. So we will compare this to physical values with our thermocouples. I'm going to also show you two other thermocouples I have that they are completely different. They are having different readings. So if you want to stay, like, subscribe, and welcome to my new video. So as you noticed here, I have ice water. It has to be ice with water, so it's gonna have 0 degrees Celsius. And the other one, I have a kettle, and we're gonna boil water. And about that ice water, it must be a mixture of ice and water, not just ice, because pure melting ice stabilizes exactly at 0 degrees Celsius. So let's put our thermocouple into this mixture. Next, I'm gonna try to show you that other thermocouples. So my thermocouple is adjusted. Well, technically it shows me 2 degrees. So later on, I'm going to show you how to adjust this value, because we can go into the settings in our controller and adjust it plus or minus 10 degrees. So it will show us a real value, not just that factory settings. So let's remove this thermocouple. Let's put different one. This one is a little bit thicker. You could see that error whenever you're gonna unplug the thermocouple. The controller sees it. So this thermocouple shows us a little bit lower temperature. It's 0.4 degrees Celsius. So technically we can adjust it completely to 0. And the third thermocouple I have, it's on that with this flexible thing. So let's put this one also. And as you can see, this one is also completely different. So technically, we should just note our value for 0 degrees on a piece of paper, and then go to our kettle and just try to boil water. So this is our 0, and let's go to 100. So I'm gonna focus just on that thinnest thermocouple, because that's the one I'm using the most. And you can see we are having our water boiling in a moment. So let's wait and see our temperature shown on our here on the display. This is our real temperature read from the thermocouple. You can see that our boiling point is 98, 99. We can adjust it. I will show you this in a moment. Technically, 1 or 2 degrees Celsius shouldn't matter that much, but at least we can verify our reading is quite accurate, and it should work with our verification. This is our first step to make a good profile for soldering without any warping or any popcorn effect. So let's wait until it will boil completely. Well, technically this thermocouple shows us exactly 99.9 degrees Celsius. So we are pretty much too high by 2 degrees Celsius. Okay, let's wait a little bit until that kettle turns off. And this is our way of verification of this thermocouples. Okay, it should turn off in a second. Okay, it just turned off. So we have 99.9 technically. So let me show you how to adjust it. So to adjust it, you have to hold your set button for a couple of seconds. It will take us to the menu. Whenever you're gonna press it again, go to the value of offset, and you have plus minus buttons, so we can go minus 2 degrees because that's our value. Go set and go out of this menu. So technically you can do the same thing with REX C100 controller. Hold the set button, you're gonna be in a menu, go to SC value, this one, and you can adjust it plus or minus with couple of degrees, and you will have your real value. To remember this, also press and hold for a couple of seconds, and this is how you adjust your thermocouple readings in the controller. So let's move on what to do next. So to verify it, the next points, I am using this two solder alloys. That on the left one we have that 138 degree alloy, and this is bismuth based, so this one should melt at the exactly 138 degrees. The other one is that tin and lead alloy 6337, so this one melts at 183 degrees Celsius. So what I would do, what I'm gonna do, I'm just gonna cut a tiny piece of those both solder wires, and I'm gonna put this on that PCB we have on our rework station to verify if it will melt on this points. It should. So here you can see both of those solder wires. On the left you have that low melt alloy, and on the right over that thermocouple there is that 183 degrees Celsius wire. So let's start our profile and measure the temperatures which this wire will melt. I'm not sure how to show you that wire melting, because I also want to show you that temperature on that controllers read from thermocouples. So you have to believe me on which point those two wires will melt. So let's start the profile and we will see. Okay, we have our profile started, and I'll let you know whenever this solder will melt. To save some time, I'll speed up the video or I'll pause it, and I'm going to show you just before the moment of that 138 degrees and 183. We are having 131 degrees too, and in a second we should have this first alloy to melt. So we have 138 and it's still not liquefied. Let's find out why. It should melt in a moment. Other thing is this alloy is from China, so it may not have 138 degrees. Okay, it's melting, but as you see, we have 160 9 degrees. I just want to show you here. It's completely molten now. I don't know if you're gonna see it. So now we should have 183 degrees Celsius. Unfortunately, it's still not melting, so our temperature is too low, or our reading is too low. So at least we know now it's starting to melt. So at 200 degrees, we know that our leaded alloy will melt. So here you can see both wires are molten now. So we know that melting temperature is a little bit higher, so we can now adjust our thermocouple settings. So now we can, as I said, we can go into that menu to adjust our temperature readings, or we just can be aware that our temperatures shown on display are at least 10 degrees too low, because I believe we can adjust just 2 degrees, and at the zero the Celsius point, 100, it's already 2 degrees or more, or even 3 degrees difference, and at that 200 degrees we are getting even more, so probably around 10 degrees Celsius. Of course, that difference can be both sides. Our thermocouple can show too high, or of course too low, so we also have to keep this in mind. And now whenever we're gonna make our profile, we have to keep in mind that our ramp rate, which is changing that how many degrees Celsius per second can we change or heat up our board, it has to be not more than maximum is 3 degrees Celsius per second. So if we're gonna go over that, we're gonna have that bending or warping effect, or even popcorning. The thing with popcorning is that if we're gonna heat this board too quick, that moisture inside that PCB or components will just expand and evaporate too quick, and this will cause this popcorning effect. We can also make our profile to keep that temperature below 100 Celsius degrees to make that board dry a little bit before soldering. So this is also other way of doing it. Of course, if you are having that IR camera, you can also verify it with your camera here. So you can, there are multiple ways of measuring this temperature. So some of you were asking me how this station looks like inside. So this is my inside. As I said, I've been using that high temperature wires to connect those temperature sensitive parts. This is the controllers. You have to take out the front panel and extend the cables. I left this transformer to power some of the parts of this station, and of course you have this power buttons, and technically this is it. I used most of that components used in this T8280 preheater. So here you can see again, and this is it. So I just lifted the top housing. Maybe just one more thing to mention, that this bottom thermocouple also can be adjusted, but I have it glued into the housing, so I am not able to, well, technically I would have to rip it off to recalibrate it. But this is how you just verify your thermocouples. So just to sum up everything, first step is verify your thermocouple reading. You can adjust it or make some offsets in both of the controllers. Second thing, you don't have to do any adjustments, just be aware what's the temperature of what's that melting point, and just so you are completely sure when to take your chip off. And the last the most important thing is your ramp rate. Do not go over 3 degrees Celsius. What I believe this ceramic heaters used here are not capable of going more than that. But if you're gonna like just run them 100% of the power, probably you will overshoot this. But in my profiles, I'm trying to use 2 degrees Celsius per second of this ramp rate, and I am not having issues with popcorning. So in my opinion, whenever you're gonna have this issue, your temperatures are way too high, or you were just having too high ramp rate. And this is it. No expensive lab equipment, just physics. Remember, check your altitude, like your place whenever you are living and using your station. This will on this will depend what temperature is your water boiling point. You have to know just 2 temperatures, and your thermocouple becomes trustworthy again. So perfect for precise soldering, reballing, and thermal profiling. If this video helped you a little bit or you like it, hit that like button, subscribe, and see you in the next one. Bye.